Okay, here we go with lesson 1.8. So what we're going to do is we're going to graph bounded. We're going to graph inequalities. They're either going to be enclosed, which means they're bounded, or they're going to be unbounded, which means they kind of go on forever. They're not closed up. So these two lines would be considered parallel. So when we're going to be looking for these vertices on the enclosed region. So when we graph something like this, graph x is less than or equal to 5, 1, 2, 3, 4, 5. Again, I like to wait. I'm going to go left of that, kind of make note of that. Y is less than or equal to 4, 1, 2, 3, 4. And we're going to be below that one. So right now we're down here, and then y is greater than or equal to negative x plus 2. Go up to 2, apply the slope, down 1, right 1, down 1, right 1, down 1, right 1. And I kind of go all the way because I'm looking for these vertices. Up 1, left 1, up 1, left 1. So here's my feasible region. I'm in here. Okay, but now here's the change. So that's the same thing that we did in, what was it, 1.7, when we just graphed inequalities. But now I'm going to find these vertices. So I've got this vertex here at negative 2, 4, negative 2, 4. And then I got a vertex at 5, negative 3, 5, negative 3. And then I have a vertex at 5, 4, 5, 4. So you find these three vertices. And now for these very generic algebra ones, they give you this region, or they give you the objective function, and they say, find me the maximum and minimum. Maximums and minimums will always occur at the vertices. So all we're going to do is we're going to plug these vertices in. 3 times negative 2 minus 2 times 4. That's negative 6 minus 8. That's negative 14. That's my value. This is where it occurs. Next, 3 times 5 is 15. Minus 2 times negative 3. That's 15 plus 6, that's 21. And then 3 times 5 again is 15. Minus 2 times 4 is minus 8 is 7. So since this is enclosed, we have both a maximum and a minimum. So we kind of say I have a maximum of 21 at 5, negative 3. And I have a minimum of negative 14 at negative 2, 4. Okay, so graph your region, find your vertices, plug it into the objective function. Next one, very similar. So I've got x is less than or equal to 4, 1, 2, 3, 4. Again, I'm going left to that. Y is less than or equal to 5, 1, 2, 3, 4, 5. And then I've got y is greater than or equal to negative x plus 6. So I'll be up at 6, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Draw my lines. I was left of the vertical. I was south of the horizontal, and I'm in this little triangle right here. Now my graph isn't very nice, but it's 1, 5 I can see there, and then this big one up here is 4, 5, and then this little one right here is 4, 2. And then we're going to put it into this objective function. Okay, so that's 4 minus 15. I plugged in 1 and 5, and that's negative 11. And then it's 16 minus 15 is 1, and then it's 16 minus 6 is 10. So I've got a max of 10 there, and I've got a min of negative 11 there. Okay, this is more realistic now. How would you use this? This is a word problem. It says, as a receptionist for a veterinarian, one of Dolores Alvarez's tasks is to schedule appointments. She allows 20 minutes for a routine office visit, 40 minutes for a surgery, so that's my time constraint. Can't do more than 6 surgeries per day. The office has 7 hours for appointments. 7 total hours. So I need to figure out, maybe I'll go X is routine office visits. Okay, and maybe I'll go y is surgeries. And now I can say the biggest thing here is this is in hours and these are in minutes. 20 minutes is a third of an hour, so I'm going to have to make that adjustment. 1/3 of an hour times office visits plus 40 minutes is 2/3 of an hour times a surgery. Can't be more than 7 hours, is less than or equal to 7 hours. And then my surgeries, I can't have more than, I have to be less than or equal to 6 surgeries, okay? So when I graph something like this, I'm gonna multiply everything by 3. That's gonna give me x plus 2y is less than or equal to 21. So I multiplied that whole thing by 3. 2y is less than or equal to negative x plus 21. Y is less than or equal to negative 1/2 x plus 10 1/2. And we'll deal with the half. It'll be okay. Everything's going to be fine. Okay, so y is less than or equal to 6. So I'm going to go up to 1, 2, 3, 4, 5, 6. And I'm going to go a horizontal line. So I got to be below that line, right? Now, this one, you could do a few different things. I would maybe put it into my calculator, find a point. But I can I can do a little trick here. 6, 7, 8, 9, 10 1/2. And I can think of my rise over run as negative 1 1/2. So down, I can go down 1/2 and write 1. If you plug that into your calculator, plug it into y equals, go to y equals negative 0.5 x plus 10 1/2. Find another point. Well, you're going to find 110 is a point. If I put 1 in here, I get 10 out. So however you need to find a point, that's fine. Down 1, right 2, 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 down 1, right 2. Okay, this is getting redundant, but I'm going to keep going either way, and I get all the way over here. So I draw this in, and we have a nice graph. Now, I was below this one, and I'm below this one. So I also need to add in, you can't do a negative number of office visits or a negative number of surgeries. So I probably should add in x is greater than or equal to 0 and y is greater than or equal to 0. And now this is my shaded region, right? So my important points here are going to be 0, 0, okay? And then I got 0, 6, which those ones don't really make much sense. This one's probably 21, right? Isn't it? If y is 0, x would be 21. It is. So that's 21, 0. And then I think this one is, well, it's 6 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 6. And that's probably going to be the winner. Now, what is my objective function? I want to make straight cash homey. $55. So what I'm going to plug in here, my total amount, my profit, my money made, my income for X and Y. So I'm going to go I for income will be $55 times every office visit plus $125 times every surgery. So this doesn't make, whoa, what happened there? This doesn't make any sense. This is $0, right? We make no money. This one would be 6 surgeries. It would be just grab your calculator, 125 times 6. And I get, this one is $750. 21 times 55 is $1,155. Okay. And now this one is probably going to be the winner. 55 times 9 plus 125 times 6, which should make sense. We should diversify our practice and get as many surgeries in as we can. We could only do 6. That means we could do 9 more. So what should we do? What should we schedule? What should Dolores schedule each day? She should schedule 9 office visits and 6 surgeries. All right. Unbounded, we got to take a look at what happens when it's unbounded. So this one's easy. Y is greater than or equal to negative x minus 2. So I can graph that one down 2. And then, well, let's graph them later. And then this one is 2y is less than or equal to x plus 2. Divide everything by 2. y is less than or equal to 1/2 x plus 1, right? Is that right? Add that over, positive, divide by 2, yep, that's good. And then this one down here, I get, I subtract that x over, so I get negative 2y is less than or equal to negative x plus 4. Divide by negative 2. Hey, watch it. Divided by negative, flip that sign. Y is greater than or equal to 1/2 x minus 2. Okay, so you can see this one and this one are, they're parallel, right? So I'm going to graph the two parallels first, actually. Go up to 1, apply a slope of 1/2. There we go. And draw a line, and I like to get a few more points. It's not a bad idea. And there we go. And then the bottom one, I go down to negative 2. I'm right there. Up 1, right 2. Again, it's parallel. We know about parallel lines. Parallel lines never cross. And we're doing great. Okay. And we're in between those because I'm bigger than this line and I'm smaller than this line. So right now I'm in between. This one will seal the deal. I'm down at negative 2. And I'm going to go up 1, left 1, up 1. Ooh, those are nice points. And I'm greater than that. So this is my feasible region. So I have two vertices. I have negative 2, 0, and I have 0, negative 2. And when I plug that into the objective function, I get 2 times negative 2 is negative 4 plus 0 is negative 4. And I get 2 times 0 is 0 plus 3 times 2 is 3 times negative 2 is negative 6. Now, it looks like this is the minimum, okay? And it looks like this is the maximum. But you got to be careful because this is not the maximum. Because if I took the point 0, 0 and just put 0, 0, 0 is in the feasible region. And I did 0 plus 0, I would get 0. That's bigger than that. And if I took 3, 1, I get 6 plus 3 is 9. So there is no max. So we have a minimum of negative 6 in this case, and we have no max. So when you have an unbounded region, you will either have a minimum or a maximum, and you probably will not have both because these values are going to keep making that get bigger. So I like to find my important points and then find another point and say, okay, do we really have a low value here or do we really have a high value? So you can check that out. And I think we're good there. I think I'm gonna stop there because I think you have the gist of it, and we'll go from there. And your homework is 1.8.